Alright, let's represent the following using interval notation. So for part A, we have x is greater than negative 2 and less than or equal to 5. So I'm going to write this as, x belongs to, if it's greater than negative 2 is not inclusive of negative 2, use the round brackets, negative 2, lower limit. And in this case, the upper limit, x is less than or equal to 5. So I'm going to use the square bracket because it is inclusive of 5. Okay, so that is an interval notation. Now let's take a look at part B. Right, so when we want to represent the following using interval notation. Think this portion here, they're basically referring to this interval here. Okay, so if they're referring to this interval here, what we want to do here is we want to look at all of the values that's greater than negative 3 but less than or equal to 3. So x belongs to greater than negative 3, which does not include negative 3, so we use the round bracket, comma, less than or equal to 3. And we're going to use the square bracket for less than or equal to. Okay. Part C here, we have two intervals that we're looking at. We're looking at negative infinity to negative 4, as well as everything greater than 1. Right? You can see that it's inclusive of negative 4, but it's not inclusive of 1. So for one of my intervals, we have x belongs to, now for negative infinity, you cannot include negative infinity within an interval because it's not an actual finite number, right? Infinity is a continuum. Negative and positive infinity represent two ends of that continuum. So x belongs to negative infinity, lower bracket, we're going to use the round brackets, comma, and because it's inclusive of negative 4, we're going to use the square bracket. Now the other interval that x belongs to here is basically x is greater than 1, right? So because x is greater than 1, it's not inclusive of 1, so 1 we use the round brackets, and this is going to go all the way to positive infinity. And once again, positive infinity is a continuum, so we're not going to address it with the square bracket. Now because x will belong in both of these intervals, we want to say it can exist in the interval between negative infinity and negative 4, as well as 1 and positive infinity. So we use this union symbol, so this means union, or just it's a really fancy way of saying or. Okay. Let's take a look at part D here. X is greater or equal to negative 5 but less than 7. If we want to draw this out, and we want to represent this in interval notation, x belongs to negative 5. Okay, we're using square bracket because it's inclusive of negative 5 and less than 7. Okay, so if we did draw this out, I'm not going to draw this to scale, but in this case, this point here would be negative 5, and this would be 7. Right, this would be positive infinity. You can see that I'm basically addressing all of this. Okay, so it's everything within this interval, and basically it's not inclusive of 7. Let's take a look at part E. So here we have x is less than negative 2, which is not inclusive of negative 2, but x is greater or equal to 4, right? So let's write x is less than negative 2 first, right? So we're doing negative infinity all the way to negative 2. We're using round brackets. And then we're going to do union, or x is greater or equal to 4. Now, because it's greater or equal to, it's inclusive of 4, we're going to use the square bracket. And then we're going to follow this off with the positive infinity with the round bracket. Okay, and those are our, that's how we use interval notation using the function method.